Hello, in this short video I'm going to investigate the following A-level problem on the topic of projectile motion. 2 seconds before a projected stone reaches its maximum height, its velocity forms an angle of 30 degrees with the horizontal. What is the speed of the stone at its maximum height? G is given to be 10 meters per second squared. Pause the video at this point and give it a try. Okay, so let us assume that this is our projectile and then this is the highest point of the trajectory. 2 seconds before the stone reaches to this point, this is this velocity of my particle that makes angle 30 degrees with the horizontal. This is 2 seconds before it reaches here. Now the question is that when the particle reaches at the highest point, what is the speed of the particle? Or if they can also ask what is the velocity, because you know that the highest point, the vertical component of the speed will be 0. So then it means that I will have only a horizontal speed, so its magnitude is equal to the speed at the topmost point. Okay, how can I use this information to answer the question? First of all, you know that here, if I ask you what is tangent of 30 degrees, tangent of 30 degrees in this right angle triangle is actually equal to the opposite side, which is the vertical component of my velocity at that particular moment in time. So this is time t. Okay, let us assume that this is time t. And we know that this t is 2 seconds before the time at which the particle has reached to the topmost point. Okay, to the top point. So this is the v component on the y component of the velocity at time t divided by the x component of the velocity at time t. But of course we know that in projectile motion the x component of velocity remains always the same. There is no acceleration on the horizontal direction. So if I ask you what is v of x at t, it is equal to v of x at initial time 0, which we usually denote it by vx naught. And then if I ask you what is that, this becomes the initial velocity speed multiplied by the cosine of the angle of projection. So this is this one. But what about that one? So we know that on the vertical direction, I have a constant acceleration minus g. So if I write the formula for Vy at time t, it becomes minus gt plus Vy at time 0. Okay, so this becomes minus gt plus, and this one is just the vertical component of the initial velocity, which is v naught times sine of that theta. Okay, so if I take them back with me and put them here, so tangent of 30 degrees becomes equal to, instead of that expression, I put this. Yes, and instead of this expression, I simply put this. Okay, this is at time t where the particle is here. But what is this t? This t has some relation with the time at which the particle has reached to the top point. But that formula, so that one is very famous. If you open any textbook on the topic, you will see that time, which I call it tau here, is v naught sine theta divided by g. So this is the time that that is the time that particle needs to reach the top point here. But if I ask you what this t is, according to the problem, the time at which the particle is here is 2 seconds before that time. Okay, so what I will do, I will go here and I would write tangent of 30 degrees is equal. I copy and paste the denominator, but in the numerator I would write minus g tau minus 2 seconds, and then copy and paste the rest. Okay, But look here, if I ask you what is V naught sine theta, you can immediately tell me that this is G tau. So here I put G tau instead. And now what happens if I multiply this in, it becomes minus G tau plus 2G, and then I have plus G tau, and then divided by V naught cosine theta. But V naught cosine theta is the initial speed on the horizontal direction. So I can write Vx naught. But this one and that one are now gone. I will get 2G divided by Vx naught. But tangent of 30 is 1 over square root of 3. So this means that Vx naught is equal to 2 square root of 3 times G, but G is given to be 10 in this problem, so this becomes 20 square root of 3 meters per second. So this is the initial velocity on the x direction. But you know that at the highest point, the velocity is exactly equal to the velocity on the horizontal direction, which remains constant during the flight. Yes? So this is exactly what I want to answer in this problem. So I wanted to answer what is Vx naught, and the answer becomes 20 square root of 3. So if I refer to this, so you see that this is the first answer. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.